Your senses rule your waking life. Think about it. We rely on our 5 senses to help us get us through each day. From our sight, hearing, and taste.
To smell and touch. Without our 5 senses, we would have a pretty tough time maneuvering through our world. Hi, I'm Jennifer Pulley.
And I'm Johnny Alonso. On this episode of NASA 360, we're going to be exploring some of the 5 senses and how NASA's using them to better understand our world and the space environment.
And we'll find out how testing cutting-edge materials can help protect our astronauts, and maybe us down here on Earth as well. But first, let's see if the nose knows how to keep astronauts safe while they're in space.
About 2,300 years ago, Aristotle first classified the traditional 5 senses: sight, hearing, touch, taste, smell. Today, we recognize that there are at least 6 other senses, including pain, balance, direction, just to name a few. But definitely, one of the key senses that we as humans possess is the sense of smell. You know, the sense of smell is a tricky thing. If you're smelling something great like a good meal or the fragrance of a favorite person, then smelling is all good. But what if you get hit with the smell of a skunk or a pile of rotting garbage? Not too fun, right? But back here on Earth, all you gotta do is roll down the window or hold your breath to try to get away from it. But in space, no such luck. If something smells bad within the spacecraft, it can actually endanger the mission, and at worst, endanger the lives of our astronauts. Think this is far-fetched? Well, the Russian Space Agency actually had to abort a mission in the 1970s because of an unusual odor. So how does NASA prevent bad odors from endangering a mission? Believe it or not, they do it with human smell testers. That's why I'm out here in New Mexico at White Sand Test Facilities to talk with my buddy George Aldrich, who works as an official NASA smell tester. George, what's going on?
Hey, Johnny, welcome.
Good to see you.
Good seeing you.
Seriously, official smell tester.
Official smell tester. I'm NASA's super sniffer.
Seriously.
Seriously.
Tell me about it.
Okay.
Yeah.
What we do here in this little lab is we do toxicity and odor testing of all the materials that go inside the capsule of the astronauts.
Okay.
We want to make sure that we don't put anything in there that's toxic, and we also don't want to put anything in the capsule that's going to be obnoxious odor-wise.
All right, so in this computer age, why don't we just use computers? Or I know that dogs have a great sense of smell. Why don't you just use dogs?
Well, first of all, astronauts are humans, and so we want to use that human connection. You know, dogs smell 10, 100 times better than we do,
Yeah.
and so that wouldn't be valid. We do have electronic noses. In fact, they have electronic noses on the space station, but it's for a continuous monitoring type thing. So astronauts sleep, and actually our sense of smell doesn't work when we're asleep. So they have electronic noses to monitor the capsule.
Where do you do all this stuff? Is it right here, or?
We have a lab. I mean, we're in the lab now that we have to do the toxicity as a preliminary. The way we do that is we put material into a sealed container.
Right.
We put clean air in it. We heat it to 120 degrees Fahrenheit for 72 hours. Then we bring it out, we cool it off. We actually inject the gases into gas chromatographs with different detectors. We can actually identify and quantify all the chemical compounds that come off that material. We put that into what I call NASA's magical formula. And if it's not toxic, then a lot of times we want to do an odor test. And so once we determine it's not toxic, then we subject it to our human guinea pig panel that NASA has here at White Sands Test Facilities.
Really?
Yes, and we're volunteers, we're employees here, and we actually have to certify our nose every 4 months.
How do you physically test the smell? I mean, you just put it in the can, kind of like inhale, or?
Let's go in the lab and I'll show you.
Good, that'd be great, let's
Sure.
go, let's
Okay.
go,
Okay.
after you. So this is the lab?
This is the lab. This
Yeah.
is where we do our odor testing.
Sure.
This is actually where we certify our nose.
Science says I can get rid of the safety goggles, or what?
Yeah, so we go ahead and get rid of the
Cool.
safety glasses. Yeah.
Tell me about this place, what are we doing?
We actually have to certify our nose. These are the 10 bottles that I was talking about.
Right.
And we've actually added chemicals to 7 of those to give the 7 primary odors, which are musky, minty, floral, ethereal, camphoraceous, pungent, and putrid.
Okay.
And the other 3 are blank. So every 4 months we have to sit down, smell these 10 bottles, identify the 7 odors and which 3 are blank. You want to try it?
Yeah, I'll be a guinea pig, let's do this.
Okay.
What is this? What's that stuff called? Camphophenique?
Exactly, it's a camphor smell.
Hey, I got one right. Check that out, man. Let's get another.
Okay,
Try this.
try that one.
Like peppermint?
Peppermint.
Yeah.
Minty.
Yeah. I'm rocking out here. Let's do one more.
I gave it away again.
You did? That's like floral. What are you talking about? He's lying to me. This guy's lying to me. So I mean, this is what people have to do. I mean, they actually
Every 4 months, we have to sit down and smell these bottles.
really.
Pass this test, be on the odor panel. If we don't pass this test, we can't be on the odor panel.
So is everything in space, I mean, tested?
That goes inside the capsule.
Yeah.
Almost everything has to go through a toxicity test. There are a few exceptions, and a lot of those materials are actually odor tested also.
They are.
We're building a new craft CEV, crew exploration vehicle,
Right.
and Orion. A lot of the requirement for it is not going to be that heavy on the odor, but it will have to do toxicity testing. We're doing toxicity testing on all new materials that's going to go inside Orion right now.
So I mean, you're learning a lot of these things up in space.
Right.
I mean, how is that going to be applied to stuff down here
Beneficial
on
to
Earth?
us here on Earth.
Yeah.
I believe that the material testing that we do here is benefiting Earth because of the fact that we're testing these materials. We're seeing what they're off-gassing, and I believe that the manufacturers are changing their formulas on a lot of these materials to make sure that they're not going to be toxic to your kids or your family and that type of stuff.
George, thanks so much for your time, man.
Appreciate it.
It was a lot of fun,
yeah,
seriously.
I had a good time.
And definitely keep number 5 locked down. That one really
You're gonna take that
sticks.
one with you.
No, but I'll take the glasses though.
Take the glasses.
I'm notorious for taking
Yeah,
things.
those are cool.
All right, man, thanks a lot, man.
Yeah.
Right on. So with NASA's help, we're learning a lot more about how to make new products less harmful to humans. Hey, stick around. You're watching NASA 360.
You know, more and more these days, really cool technology is aiding us in our lives. And one of the coolest is voice recognition software.
Say a command.
Call Johnny Alonzo.
Calling Johnny.
Right? You say your name into your phone calls that person. Now, while that technology is advancing pretty quickly, a researcher at NASA is already working on the next generation vocal technology. It's going to allow us to give commands without even speaking. Dr. Chuck Jorgensen is working on something called subvocal speech applications that may make it much easier to relay commands or have conversations in space, while also helping accident victims or those with physical impairments back here on Earth. Here's how it works. Basically, when any of us speak, nerve impulses are sent from our brain to our vocal cords and tongue, and voila, words come out. But even if you're just talking to yourself and no one is actually hearing the words come out, nerve impulses are still being sent to your vocal cords. So what Dr. Jorgensen is doing is attaching small button-sized sensors to the throat to pick up those nerve impulses. These sensors recognize the words subvocally, so even if no one hears a word or even sees your mouth moving, a command can be sent. So in the example of an astronaut, if a command needs to be sent to, say, a rover, the astronaut can control the vehicle remotely without having to touch any instruments or give any vocal commands. Of course, there are obvious advantages to utilizing this type of device here on Earth as well. For example, it could be used to enhance medical equipment for injured or disabled persons. And it could help people in their jobs where they can't speak out loud due to physical conditions or locations, such as air traffic controllers, underwater divers, or military personnel. All in all, I would say this is a pretty cool technology, wouldn't you, Johnny?
Totally, Jen. All right, let's switch gears and check out another cool facility here at White Sands that is helping us make our astronaut crews even safer. Come on, let's roll. Now, since the late 1950s, when we started sending rockets and satellites into space, the area known as low Earth orbit has become pretty cluttered. There are millions of man-made objects and naturally occurring micrometeoroids that are swirling high right above our heads. One of the main challenges NASA faces is to be sure structures, vehicles, and spacesuits are safe. But how do you test them to withstand the impact from these small particles? Well, check this out. There's this really cool facility here at White Sands that does just that. Let's head inside and meet my friend Karen Rodriguez, who will show us how NASA tests hypervelocity impacts. Karen, hey, how are you?
Hey, good. How are you doing?
Good to see you. Wow, this place is something else. Tell me, what's going on here?
Well, what we've got here is our remote hypervelocity test laboratory.
Okay.
And what we do is we utilize two-stage light gas gun to simulate micrometeoroid and orbital debris.
So why do you do hypervelocity testing?
Well, there's over 100,000 metric tons of debris in space. And this debris is traveling in various orbits around the Earth.
Okay.
And so we have, of course, the International Space Station in space, and we have the astronauts going up in the shuttle. And so we want to protect the astronauts, the International Space Station, from this debris. This is NASA's #1 risk, and we want to make sure that the astronauts are safe and that they can come home safely to their families.
Of course. So how do you decide what to test?
Well, it's a real interesting question.
Yeah.
Actually, what we do is we work very closely with Johnson Space Center
Okay.
and a group over there called the Hypervelocity Impact Technology Facility. What they'll do is they'll perform an assessment of the shuttle after it has gone into orbit. And when it comes back, they'll look at the size of the debris for the impacts that were created. They'll take that information and look at their existing models and then determine what size of projectiles we need to shoot. Now, we shoot spherical projectiles, but not all debris in space is spherical. But for modeling reasons, it's actually easiest to model spherical projectiles. Now, what they'll do is they'll look at different densities of the materials that are actually in space. So not just micrometeoroids, but of various explosions, impacts, anything that may have occurred in the past that has generated new debris. They'll look at what type of material that is and then choose another material of similar density and choose that material for an impact.
Do you have any examples around here?
Actually,
You do?
we do.
Hey,
Thank you.
what do you got?
So what we've got is a nylon projectile and an aluminum projectile. Now these are just two different sizes, but there's actually a variety of materials that we can test.
Okay.
Aluminum, stainless, glass, anything. So pretty much any projectile that is an inch and smaller we can test. So what we have in here is 50 micron projectiles. Now you can kind of see the dust down there in the bottom, but it's really tiny.
Right.
And we can shoot one of these as a single projectile all by itself.
So here's my question. I mean, why would you want to test something that small? I mean, how can that hurt somebody in space?
Well, the reason we want to test projectiles these small is because there's a lot more of smaller projectiles in space.
But how can that hurt an astronaut?
Well, you've got a more abundant amount of these small projectiles. And because you can't track it, if it impacts the astronaut spacesuit or even a shuttle glass window, the damage varies, and so that's why we do a variety of testing. There's a paint fleck that once impacted the window on the shuttle and it created some damage to it, and then the question being, of course, you've got a vacuum in space, and how does that compromise the material properties of that piece of glass once it's been impacted?
Oh, wow. So Karen, it's really hard for me to understand these speeds, and can you give me an example?
Well, if you can imagine traveling from the East Coast to the West Coast in approximately 10 minutes.
Yep.
That's how fast debris is traveling up there. So it's not just the astronauts that we're wanting to keep safe. You've got your satellites up there that are for your television and for your cell phones, and so who knows what'll happen if those satellites are impacted.
Wow. So this is an actual gun then, right?
Yes.
Yeah, tell us how it works.
All right, this is our 17 caliber launch range.
Right?
We've got our end cap, and this is where the gunpowder is loaded.
Sure.
Now inside here we have a piston. This is an example of what one of the pistons look like.
Okay.
Now the piston is inserted into the pump tube section of the gun.
Gotcha.
Have a vacuum, and then we fill it with hydrogen. Gunpowder burns, accelerates that piston forward, compressing the hydrogen gas. This is our high pressure coupling. Now what we have in here is a tapered section.
So the projectile is here, right? And the gunpowder is all the way down there, right?
Right.
Why?
Okay. This is a two-stage light gas gun.
Okay.
If you have a single-stage gun,
Right.
conventional methods won't allow you to get to the velocities that you need to achieve to simulate hypervelocity debris.
Okay.
So we have this section of the gun because we need the two stages in order to compress the gas, in order to accelerate the projectile to a high enough velocity to simulate that micrometeoroid and orbital debris. So the pump tube has compressed that hydrogen gas into this section. We have a pedal valve, which then ruptures and allows the high pressure gas to accelerate the launch package forward. So this is our barrel,
Right.
and it has a .17 ID diameter bore, thus a 17 caliber gun. Inside here we have the launch package. The launch package is then accelerated forward from that compressed hydrogen gas
Right.
into our flight range. Once the launch package gets into this section, the projectile then enters free flight. And so we capture the velocity as the projectile breaks the beams of the laser station. The projectile continues down into the target chamber where we have our test article fixed.
Right?
And then we get a nice impact, we collect the images, and when the test is done,
Yeah.
we pull it out, got a beautiful target.
Let's go take a look.
All right?
Come on.
All right, so what's going on now is Paul's opening up the target chamber.
Right.
The test is just finished, and
Sure.
he's getting ready to pull the test article out.
Okay.
Now, see how he took that out right through the crosshairs?
Yeah.
Isn't that great?
Totally dead center.
So this is the test fixture
Gotcha.
that they use to mount the test article.
Uh-huh.
And if you look down inside the tank, you can see the barrel is coming through. We've got our flight range,
Right.
and it's coming through, and that's the direction the projectile travels, and it would come through and impact the test article. We have our high-speed imaging systems, which are capable of 200 million frames per second.
Wow.
So what happens is we have the cameras right over here. They shoot across the target chamber, and they capture the projectile in flight prior to impact.
Karen, thank you so much for having us.
All right, Johnny, thank you for coming out. I'm glad to have NASA 360 joining us out at White Sands Test Facility, and hope to see you soon.
You definitely will. Thanks.
All right, so what happens if a spacecraft actually does get hit by a piece of debris? It will be hard for the crew to get out and fix it. So what if the spacecraft could actually heal itself? I know that spacecraft healing itself sounds a bit far-fetched, but in reality, researchers here at NASA are developing self-healing materials that are going to be beneficial to astronauts and to those of us who aren't. It is so hard to imagine. These unbelievable new materials being developed at NASA, when you puncture them, they seal up. They basically heal themselves. It's crazy. Think about it. If you were lucky enough to be an astronaut living in a space habitat, you would want to keep the oxygen safely inside, right? Without a self-healing material, a strike by a micrometeoroid or other object could mean the end of a mission. So how can self-healing structures help us here on Earth? Well, it could be used for a variety of applications, from protecting fuel tanks on aircraft to strengthening windshields. This revolutionary technology really has unlimited uses. I spoke with my friend Dr. Mia Siochi at NASA Langley to find out more.
Self-healing material that we're working on is a polymer, essentially it's a plastic. And what we're trying to do is design it so that it's got the right properties so that when you shoot at it or something goes through it, the temperature actually goes up so that the material flows a little bit. So after the projectile punctures it, you actually have the material sealing back up in the back. And it's a good enough seal so that you can actually retain liquid in there, for example, or air.
This is, I mean, it's amazing. I don't understand. How'd you come up with this idea? How does this happen?
Actually, you know, this was a material that's been around for a while. It's a commercial material that people are using for golf ball covers. And somebody discovered that they're also using it in shooting range for target. Basically, it's a reusable target. Is there something that we can use this for space applications? Now, it's an interesting material for us because we can think of a self-healing system where we do not have to go back and repair it. If you have a material that will close back by itself, then you can think of it as another way of having more durable materials out in space. Now, why are we interested in this? Because, you know, if they already have a material that they're using out there for shooting range, the properties of a material that can survive in space are different from what they need to withstand, say, out in the sun over here. And so we are trying to design a material where it can meet the requirements for differences in temperatures and radiation resistance out in space.
You mentioned bullets
Yes.
earlier, penetrating through this polymer, the self-healing material. Show me what you have here. This is amazing. I mean, this could save lives.
Yes, it can. So this is a polymer sample that we have shot. It's marked here 22 caliber, 35, and 45. So let me show you an example of what a 22 caliber bullet looks like. It's like this, and so it had penetrated through here and came out the other side, and so you can hardly see where it went in. And this is a 45 caliber, and so it penetrated, and that's the hole. And it's a bigger diameter bullet, but still heals back up.
So it's a real seal. I mean,
Absolutely.
It's almost back to originally how it was.
Yes, it's almost back to originally what it was as far as the mechanical properties, but the seal is perfect.
Okay, so I understand the penetration here. What if you cut or somehow tear apart this polymer, this self-healing material? Does it go back together?
Well, it depends on the conditions that you use that in. For example, we have done it so that when you cut through the sample, it warms it enough so that it seals back behind itself, so that when you pull on it, it actually is together. Now, granted, that seal is probably not perfect. You won't get the original properties. However, if you have to use it just to not have catastrophic failure, you can at least get there.
So Mia, practically, if I was an astronaut in space, self-healing materials are going to keep me safe. How?
Absolutely. For example, if we use this material in the habitat, then if the habitat gets punctured, rather than deflating, losing all the pressure in it, it can seal back up and retain pressure in it so you can have a livable environment in there. Even farther out, if you can have this kind of material in an astronaut suit and they're working outside, then it'll protect them from the life support systems that are already incorporated in the astronaut suits.
So obviously beneficial to astronauts in space. What do you foresee as benefits to us here on Earth?
One thing that we've thought of is car windshields, for example. You know how you sometimes are going down the highway and you get pebble hitting your car and it causes a crack in the windshield and you have to replace it. In this case, we're hoping perhaps that if that happens, then the glass behind it actually seals, so you don't have to replace your window. Saves you money, have a more durable windshield, and it's safer for you. There are other things like wire insulation. The insulation chaves, and then you have it cracking, and then you have arcing, right? Okay, and so that's unsafe wiring. And if we can use this type of material, then you can have a more durable wiring in various applications that will last longer.
Mia, I am amazed at this technology. Thank you for sharing it with us.
You're most welcome. My pleasure.
And just remember, if you look around you every day, you're going to find technology, inventions, devices that originally came from NASA. Trust me on this one. More of those inventions are yet to come. That's it for now. For Johnny Alonso, I'm Jennifer Pulley. Catch you next time on NASA 360.
Think about it.
Just remember, if you look long enough and hard enough all around you in your everyday life, I mean, you're bound to find inventions. Now it's me again. Sorry.
But one of the key senses that we... Two? Okay, got it. Today we recognize that there are at least 6 other senses, including pain, balance, and direction, just to name a few. But definitely, one of the main...
From smell... Nope. To touch and smell. Call Johnny Alonso.
Contact. Please choose.
It's not working.
Totally, Jen. All right, let's switch gears and check out another cool facility here at White Plains. That's right? White Plains, New York. White Plains, does it look like White Plains, New York to you? Right now there are millions of objects, man-made objects, almost, yeah.
Blooper. I love when the researchers have bloopers.
How are you?
Good.
Good, good.
Good.
Tell me, so what do you do here? First of all, wait, official, do it again. Since the late 1950s, when we started sending satellites and rockets into space. So,